CloudDB, shaping your new normal.
Hello, everyone, and welcome to today's session at the 2022 APEC Database Days by Apaco UC. This is our first year having a dedicated database event, and it's our honor and privilege to run this event with the support of 15 Oracle user groups and jugs in the APEC region. Please remember to register to as many sessions as you can. This way, you'll be able to have access to our replays until May 20, 2022. I would like to say thanks to all Oracle user groups and Java user groups that made this event possible, and also to our sponsors, Oracle ACE Community, the DevRel team, and our main sponsors, Oracle Corporation and CloudDB. Now for today's session, Information Lifecycle Management, Manage Exponential Data Grow, a live demo by Chandan Tanwani. Please feel free to ask questions by using the chat window on your right lower corner of your screen, and Chandan will be answering your questions at the end of the presentation. If any issues during the presentation, please use the same chat window, and I will do my best to answer your questions and help you to solve the issues. Now, without any more further ado, I want to leave you with this amazing session by Chandan Tanwani. Chandan, the room is yours. You can share your screen.
Yeah, thank you. Thank you very much, Francisco. It's my pleasure to, in this APAC Oracle user group and presenting the session and this database days 2022. Yeah, so thank you very much for the session and joining me. So journey so far, just a bit about me. I'm working with Oracle, for the technology that I started working with the Oracle 7, and I started work and continues to work on the Oracle 19c and beyond the Oracle databases. I'm a performance tuning certified expert and also a cloud infrastructure architecture professional, and works on many things like middleware, database technologies. I'm very much passionate about Oracle technologies. You can follow me on Twitter, LinkedIn, and also you can follow me on my blog spots. So let's start today's session about the managing the data, that is the exponential growth that we are seeing nowadays. Data is very extremely valuable, and with the digital transformation at every stage in the industry, data volume is increasing like anything. In organizations, variety of applications are running and variety of data is generated from these applications. So my means in data, different varieties in the different forms, like relational, non-relational, documents, files, videos, images, like anything, and the volume, velocity, and variety is like increasing by any stage, right? So now the challenge for every organization is how to manage this data, because data is growing exponentially day by day. Businesses capture the data amounts that are sometimes it's overwhelming. So mostly when you think about the Internet of Things that provides countless data points from its machine, sensors, cameras, and other points. According to the IDC, more than 41.6 billion connected IoT devices or the things will exist in the 2025. It's generating alone it's 79.4 zettabytes. So we can say here that this, the data residing into that, but increasing the storage will create another problems, like increasing the infrastructure, reducing the performance, higher maintenance, like your tuning and archiving of the data, and you may think of what. There are many problems occurs with the growing your data increasingly. So what could be the solution for this, right? What you can think the solution to manage all this data? So solution is information lifecycle management. In this term, used interchangeably, like data lifecycle management or the information lifecycle management. Information lifecycle management is the practice of applying policies, the effective management of the information throughout the useful life. ILM of the database includes every phase of the information from its beginning to the end, and it consists of the policy, process, practice, and tools that you align to your business value of the information and appropriate for the your infrastructure IT cost, right? So that is the ILM, or we can say information lifecycle management. The customers value different parts of the data differently. I'm saying that different parts of the data differently. Why differently? Because most recent the data is accessed frequently, and as the time flies, like a previous years, the data will become history. The most recent data and the historic data usage is from the different purpose, have the different use cases, hence associate different cost for storing the data, and the objective to apply the right storage optimization to the right data at the right time is very much is required, right? So uh, Oracle database provides the ideal environment for implementing your information lifecycle management solution, because it offers the very cost-effective solution that is very transparent to your application and achieve all this without any compromising your performance. And here I can say it drastically improve your performance, rather decreases your performance. It will improve your performance. Mm, Oracle ILM solution is based on the combination of partitioning and compression. This combination will help you to achieve information lifecycle management. In other words, I can say data lifecycle management. So step one is your data partitioning. Step two is the data compression, and the combination of both, like we can say step three is your data information lifecycle management. It helps you to achieve, to define the policy, manage your data movement, and I can say distribute your data across multi-tier storage devices. Or I can say, you are dividing the data across your different storage tier, mount points, table space, that we can say. So let's look at our very core part of partitioning and the compression, and finally we will see how we can achieve information lifecycle management, which helps you to define the ILM process that distribute data accordingly in multi-tier storage devices. And I will showcase you the live demo of this ILM. So very first thing that I want to talk about the data partitioning. So this is the very first step. Oracle partitioning can greatly enhance your the data manageability, performance, and availability of the almost of all the your database application. There are various partition strategy available in the Oracle database. You can have a range partition, hash partition, list, interval, all the combination of different partition strategy. Like you can composite partition, so two partitions are a part of your one table, right? So let's have one example here. So when data volume increases, common concern is that the system performance will degrade because of all the extra data that has to be examined, right? And Oracle partition will help you to eliminate those problems and limiting the amount of data to be examined or operation. So here in this example you have one very large table, and it is when we access the table more than 60-70% of the data, it will do the full table scan, right? But what if we have the partitions in place, and only the that particular partition is touch upon to fetch the data, and you are eliminating all other partitions by uh, the query that will improve your query performance, right? So in this way, in this fashion, that you are increasing your data performance. and your query performance, I should say, and the data manageability is very helpful to you. So remember, this color coding is, I have make the color coding is like some partitions are in red color and few are in blue and few are in yellow colors, right? So what we here say is, you can do the partition strategies like you have the current and previous transaction, you have the old transaction, and you can have the very old or historical transactions. So by this way, the partitions, you do the partitions according to your business strategy or the business operations that are going on in your organization. That will actually improve your query performance and data manageability. Like here, we have seen in this example, current, previous, old, and historical transactions are managed in different partitions, right? And the implementing partitioning is, it will you can do it's online actually. So no need of any application changes is required at any point of time. No coding change required, no query changes is required, nothing. So it is transparent to your application. So no developers needs to be involved for this, changes in query changes or code changes, right? You can define the policies, for this partitioning with the help of your DBAs and developers together, right? So the benefit with the partition is like the partition works only with the relevant data. It will omit all the other data or partitions because your query process is doing on this partition itself, on the particular partition where your data reside in. So it will helps you for the data loads, joining, index creation and rebuilding, or it will optimize your statistics and also the backup and recovery. So that all are the operations that is increases your performance, and that partition data manageability will be increased. Now coming to the next portion is the second phase, the second steps that I can say, it's Oracle Advanced Compression, right? So Oracle Advanced Compression, it's really will help you to compress your data. There are different strategies. There are different, you can say, advanced compression is having a row compression, LOB type data compression, index compression. It also have the RMAN backup compression to reduce your, daily backups and your full backups, your incremental backups with the RMAN, or import export that you are, you are taking the export backups for your, you can compress those. And also it will help you to the, for the data guard environment, it will compress data is move over the network from your primary to standby side. To implement the compression, similar like a partition, there is no application changes at all is required, but there are many key benefits. I should say, the key benefits of advanced compression is to increase the query performance. Oracle's database ability is, when you have the using the Oracle advanced row compression to read the process, the compressed data and the indexes directly in the memory without uncompressing the data. So this is what you are getting the benefit. Without uncompressing the data, you are directly accessing to the compressed data actually. So this helps you to improve your query performance due to the reduction in the IO and the reduction in the system calls that related to the IO operation. So further in the database buffer cache, that will also become the more efficient by storing more data without having to add memory to the SGA or the buffer cache. So your data, compressed data is residing in the buffer cache. So that benefit you are getting, and you are directly accessing the compressed data. Say for example, if I today without 8 KB block, today without compression, I'm residing 100 rows into that. But after a compression in the same block, the 1,000 rows are residing, right? So your system calls, your IO is drastically reducing, because in one single system call, it is, taking your 100 rows, it is carrying 100 rows, whereas earlier it was carrying 100 rows, and now it is carrying 1,000 rows after compression. So it drastically reducing your IO drastically reducing your system calls, and you are getting the benefit of the advanced compression. And as we have seen that, the customers are typically reports us to, and they are getting 2x to 3x improvement in their query performance with the data compression. And it will actually help you to reduce your storage as well. So we have seen that customers are, having a minimum 2 to 3x, storage improvements they are getting with the advanced compression. So the other key benefits that I have talked about, the redo transport over the network. It also works with your transparent data encryption, and also it will help you to achieve your backup compression, your ARM and your export backups compression, and the automatic data lifecycle management. That is the we are next in the slide we will see about that will help you to achieve this with the compression, right? So compression features is like now you may wonder, means this advanced compression is suitable in OLTP or in warehouse. I can say it is suitable for both workload, OLTP and warehouse workload. Advanced compression can be implemented anywhere, like anywhere your database is deployed on premise, over the cloud, or any hardware platform. But for the Oracle storage compression, like in the bottom of, you can see the hybrid columnar compression is only for the engineered system, that is the Exadata only. So not available for the commodity hardware, but advanced compression is available for any where you are deploying your database. Right. I just want to showcase you the one of the largest customer advanced compression advisory report, where they have run this advisory report only for the 45 tables, and it's tables containing 1.85 terabytes, right? And the reduction of the drastically the storage tier is 0.76. They are getting 2.4x storage benefit with the advanced compression. So this is just a highlight of one of these data points that we have captured with one of the customer. Another portion, like now coming to the third thing. So first step we have did the partitioning, second step we did the advanced compression, and third step now we are seeing is the how to implement data lifecycle management, combination of both this partitioning and compression. So we have now we discuss about means how to achieve this data lifecycle. So very first thing, we have the very large table, where we have seen this is very difficult to manage. We have partitioned this table, and we are improving the performance as well as the manageability of this, right? So combination of both is help you to achieve the manageability. But what if we have seen that current partition, current and previous transactions, old transaction and very old transactions, right? We have bifurcate those transactions, but now we should bifurcate those transactions into the at different level. Let's see, it's we are defining the different table spaces for each of every partitions, like we have defined for the current and previous years. For example, it's a 1 year of the transaction, it's for the current year of transaction. And when the time flies, so your transaction become old, those partition will automatically move from one table space to the another table space, or I can say one storage tier to the another storage tier, it is moving, right? And once the time again flies, it become the historical transactions. Then again the data movement happens automatically from your old table space, which is the low cost storage table space. Then you are moving it to the archive storage table space, right? So this entire process will become automatic if you implement the data lifecycle management. So how this actually happens, right? How this actually happens, we will see in the next slide, means how this happens. But I want to say many customers as of moment are doing this data movement manually. They are writing the custom scripts like they are fetching the data which is the old transaction, 6-month old transaction. They are moving it to the creating a new archive table or historical table, and they are copying the data into the new table and deleting the data from the original table. So as of moment, the many customers are doing like that, and they are writing such a scripts. They will run in every quarter or 6 months or a year of time. They are running those scripts manually. Why not here? You should adopt those things as a automation. Not only the data movement or moving your partitions to the different storage tier, but automatically compress your data when the data is become old, right? So it is the automatic compression plus automatic data movement that is will be become a part of your database with the help of this data lifecycle management. So let's understand how this will work actually. So uh, uh, did advanced compression have these two technologies. One is the heat map, and another is the automatic uh, uh, data optimization. So remember this three color code which I have kept in this slide is the red, yellow, and blue. Okay, so red, yellow, and blue will help you to understand the how the data movement happens in my subsequent slide, right? So let's talk first talk about these two new components of the advanced compression, that is called the heat map and automatic data optimization. So here, the advanced compression, these two components will help you to achieve this. Heat map automatically track usage information at the row and the segment level, right? And the data modification, like times are tracked at the row and you can say aggregate level of the block level, and that it will scan entire your table and that segment level and identify if there is any modification happens into that or not, right? And or ADO, the automatic data optimization, will help you to define the policies at at the row level, at the table level, and at the partition level. It is being evaluated and executed automatically in the background during your maintenance window. That is, the maintenance window is defined by your DBA or the default maintenance window. Okay, so DBA can also execute it manually, rather automatically in the maintenance window. Anytime you can define those policy, and you can execute those policy manually by simple command or scripts at any point of time. So ADO policies basically specify, the type of the conditions of the data access that will trigger the ADO operation. So such conditions are, the data no access, the data no modification, or the, creation of the time, means the time flies, you can, move your data. And when the policy will take effect, for example, number of days, or the number of months, or the number of years that you defined in that policy. We will see how this policy you can define with the ADO, and the automatic data movement will happen with that, right? So remember the this color coding, that red as a hot data, yellow as a warm data, and blue as a cold data. So heat map will track the data usage and determine whether it is hot, warm, or cold. So this color coding is only just for your understanding purpose, to how the heat map will work. So heat map and ADO are enabled with the init.ora parameters is like heat map underscore heat underscore map, that you can on and off it. At on means you are enabling it to track your data, and off means it will disable your tracking of the data. Remember that the objects which are residing in the system and sysaugs table spaces will not be tracked. Only the user's table space data will be tracked. Okay, so your user defined table space are tracked only. So automatic data optimizations will allow to create a policies for data compression as well as the data movement to implement automatic tiering of your data compression as well as the storage tier. So let's say example means how this stuff will work, right? So say for example, hot, warm, and archive data, when the data is coming into your tables, right? So very first thing, advanced row compression will help you to achieve the 3x compression. And when the this data becomes warm, like it is no use of a modification at very first time, then it will again you can compress it in a columnar query compression, so 10x compression. And once it is the data is cold, there is no modification after certain period of time, it will again move from warm data to the archive data. And that will become more compression, like columnar compression you can achieve if you have the exadata. In commodity hardware, you can achieve the data movement plus compression, but in exadata you can achieve the different level of the compression: row compression, columnar query compression, and archive compression, like that, right? So let's understand this with one of the example that I want to share with you. The scenario that how the large table can be partitioned by time. In this scenario, the DBA wants to automatically compress older partition when the activity cools down and the updates haven't happened in a while. So he will create a two ADO policy on this table, like one to implement row-based compression after 30 days of no modification, and one to implement the columnar compression after 180 days of no modification. So these two policies are defined on top of this order table. Now, as the data is inserted in this table over a time, it will automatically partitioned, and the slide shows that the newest partition are hot in red and the older partition are cooling off to the yellow color, right? And when the cooling partitions meet some conditions, so the ADO policies is applied, they will automatically will compress the data. And with the row based compression, the advanced row compression features that will be applied. So you can see here the cooling period, like the blue partition is automatically compressed after 30 days of no modification. So when the partition become cold or infrequent accessed, or 180 days polish will also applied, and partition further compressed compressed to the next level. So by this way, you are having the automatic data compression as of moment. Now, as more data comes into, the more partition will cool off, and the will get space, and your table space is getting full. So what you can do is, you can move your partition from one table space to the another table space, or we can say one storage tier to the another storage tier. So let's look at other thing at the customer want to handle the large table and storage tiering. So in addition to that, the compression policy that we already implemented, let's add one more storage tiering policy that will move data from low cost storage to the high end storage to the low cost storage. So currently table space is it is most aggressively, you can have the different compression level. So we are adding more third policy into that. So the cold partition, which is then the blue color, which is no modification of certain period of time, it will automatically move from one table space to the another table space. So this policy is applied, and it is compressed the data and move from one table space to another table space automatically. There is no human intervention is required. So that will actually you can achieve with by just defining the policies in your database for that particular table, and the partitions that is into that tables. So we will see this in our live demo as today in this session, right? So I should say there is no application changes at all, no query changes, no code changes, or no any other application side changes as required. So you can free developers for these operations just you can take a help of developers when to partition, what are those partition strategies you can implement, and the business impact of the partitioning and compression, how you want to define the policies and implement the data lifecycle management for your application, right? So nothing can be changed at the application tier or application level. Only changes can be happen at the database layer, at the database level only. Now let's see how this live demo, how this will work. So I have this, live demo with me to showcase you. So say for example here, I'm creating a one table, which is, partitions. There are two partitions over there. I'm inserting, you can see here the compress is disabled as of moment. So what we'll do in this demo, actually, we will implement two policies. One is for the compress data automatically, and the data partitioning movement from one table space to the another table space automatically, right? So as I have created this table, I need to insert the data first. So I'm inserting the data 5 lakhs rows in the first partition, and again the data insertion for the next 5 lakh rows into the second partition, right? So to arrive, how much space I'm getting benefit with the compression and how the data movement happens, I need to gather the table stats, right? So I'm gathering the table stats for this particular table. And you can see here, the compression is disabled. You can see the 5 lakh rows in the one partition. And remember this, the blocks, 6363 blocks are there. And the table space, which is, here in this fast storage table space. And this partition is having the 56 MB. So 5 lakhs rows, 56 MBs, and blocks are 6363. So what I'm here is doing here, my heat map. Okay, so heat map will track entire things. So he is tracking that, there is an insertion in the table, there is a, that much of data is available in this partition and in this table space, right? So you can see here with the, V dollar heat map segments that track time. It's a current time in my, time zone. This is tracking this entire partitions and tables, right? So what I will do here, I will apply the policy. So to compress the data after 30 days of no modification. So what I have did, I have alter this table and keep that ILM add policy row store compress advance. Okay, and segment after 30 days of no modification. Okay, so here I have kept this, that after 30 days of no modification, right? So once the 30 days is over, it will track entire 30 days. If there is no modification in that particular partition, the data is compressed automatically. But today for this demo, we don't have a time of 30 days. So I have make a changes is something like, we should wait for 30 seconds, right? And I will manually trigger the ILM policy, rather waiting for the maintenance window. I will trigger it manually so that you can see the effect this automatically data compression happens. So you can see here the, with this user ILM data moment policy, the action type is the compression at the segment level, the compression level is advanced, and the policy type is no modification after 30 days, right? So this policy is defined now. So what we need to do is, I will flush the data and heat map to track it that 30 days we haven't modified anything, right? So what I'm doing is manually flushing the data and asking heat map to track this as a 30 days, but we should wait here for 30 seconds as of moment, right? So let's wait for 30 seconds. Behind the scene, what will it will do is like, it will calculate those seconds that there is no modification for that particular partition. So I'm not as of moment modifying anything in that partition, like any insert or any update or any delete for that particular partition. Okay, for that particular data segment, I can say. So I'm not modifying anything as of moment. Hence, the heat map is tracking the same thing, that there is no modification happens, so that I am eligible to apply this policy, and the data compression happens for this. Right. So I think the 30 seconds we have completed. I have explained means how this actually will work. Right. So I'm waiting for a few more seconds to, to complete it, so that we can have the exact, the result of this. Right. Generally what happens, this policy, the um, uh, background process will automatically apply this policy, and the data compression happens automatically. But in this live demo, I cannot wait for 30 days and for background process to do it, because the background process will do at the maintenance window. Right. So I need to fire this command. So what I have did, I have fired the execute the ILM policy right away and show us the result. Right. So now let's check the policy. Though this ILM policy is applied, this is my current time here. It is applied now, and we can see it is the completed successfully. The ILM policy is completed successfully at this time, and let's see the result. So you can see here the now the this partition CPT ILMZQ1 is enabled. Compression is enabled 5 lakhs rows, and now the blocks are 790. Earlier it was the 6363 blocks, and now it's 790. And you can see is the fast storage table space, and now it is 8 MB only. So earlier it was 56 MB data. After compression, it become the 8 MB only. So this is the power of the advanced compression, that it drastically compress your data and increase your storage tiering, right? So with this compression, which is having the heat map and ADO, we have applied this policy, and automatically data compression happens. Now again, I'm want to add one more policy. As you have seen, we have this fast storage table space. I want to add one more policies, like the data, this partition will move from fast storage table space to medium storage table space. So here you can see the medium storage table space which I have in it is online. What I'm doing is, again, I am defining one more policy for that partition, which is ILM add policy to the tier to medium storage table space. Read-only segment after 30 days of no access. Okay, so there are certain things: no modification, no access, and the creation of time. So these three conditions you can define in this command. So what I have defined is no access of this 30 days, or no modifications in for this 30 days. The policy will apply. Right. So again, similar way, you can see this is the second policy, which is the storage type, and last access time is 30 days. But here in our example, right, we need to wait for the 30 seconds. Okay. So what I'm doing, again, I'm flushing the entire data, and then we should wait again for the 30 seconds to complete it. So this is drastically, for this demo purpose only, I have created such thing like we should not wait for 30 days. We should wait for that 30 seconds only, right? So this policy is, what happens behind the scene. It will move entire partition from fast storage table space to the medium storage table space. What that will actually behind the scene it will do. So manually, I will execute this ILM policy again to showcase the demo. Right. So let's wait for a few more seconds to, track heat map will track it out, means any access is happening or not. So as you see, I'm not doing anything for that particular partition. I'm not accessing that partition, neither doing any select, neither, neither I inserted, updated, or deleted any data from that particular partition. So what I'm doing is just I'm waiting for to complete this 30 seconds. So this is a very a simple command that you can deploy in your environment. You can define your own policies based on your business requirement or the business policies that you have to archive your data, or you can say data once your data become older, you can move your data from high-end storage to the low-end storage, or you can move to the different table spaces, so that you can have the data manageability plus data performance that you will get for your query performance. Generally what happens in our environment, we always fetch the current data, which is current data means the current year transactions are are modified or inserted or deleted the data for those purpose. But previous transactions like a 1 year old data or 2 year old data are never modified. On top of it, we insert to the data. We never modified those data because transactions never be modified. It is inserted on top of it, right? So let's see. I have executed this policy manually. We have seen this 30-second completed. Now you can see here the the partition is compressed itself, but here the table partition table space name you can see is the it is moved to the medium storage table space. The entire partitions move to the medium storage table space, and another partition, this q2 cbt ilm q2, is the it is a fast storage table space is still there, because we haven't applied that policy to this particular partition. We have applied policy to the one partition only, right? The similar way you can apply the policy to entire segment and different partitions, right? So partition creation is also automatic. As and when the data comes into your table, the new partition is created automatically, and then this policy will apply automatically to the entire segment. So this demo, we have seen this, the two policies we have defined and two things, the automatic data compression and automatic data movement, or I can say automatic data archiving we have did with the defining these policies. So entire things you can manage within a database. Earlier what happens, we were doing certain kind of the scripts we've written into our in database, like the data which is very old, we are fetching those data and keeping in the historical tables and deleting data from the original table. No need to do those stuff. That is part of your database only, and you can have those data within a database rather moving here and there the data in different table spaces, sorry, in different tables, actually the historical and original tables, right? So this way you can do the data manageability. You can achieve the performance, and also you can scale your database at any point of time by adding more storage, more table space within your database. So coming back to this, our data lifecycle management, we have seen this things works. To summarize, actually, this entire session, if your organization is most likely to, the data volume increases like anything in every 2 years or 3 years, this is the best way to do the data manageability with partition and compression, data archiving with this compression with the ADO policy, and also the data movement with the with this ADO policy. So not only you are managing your data, but you are increasing the application and database performance, as well as you are managing your data, right? So that will really help you to achieve, and many of the customers have adopted this solution rather having the manual scripts to write the data archiving or managing the data, right? So just want to showcase you, across industries, whether you are in financial institution or you are in industrial manufacturing, healthcare, pharma, or any other food processing, port and shipping, real estate, every customer using this partitioning and compression, and they are doing the data lifecycle management on their own with the by just defining the policy. Okay, so no manual intervention is required, no human intervention is required. DBA has to, just define the policy, and that's it. Everything is taken care by Oracle background processes, and everything is taken care at the defined policies. So thank you very much for joining me, and thank you very much for this joining me in this session. I'm happy to, if you have any questions, you can, ask me either today or, any point of time. You can connect me as well, so we can have this, questions so far.
Hi, Chandan. Thank you so much. Excellent session as always. I just able to see a couple of questions. They arrive in the chat. The first one is in partitions. Do we have features like can inactive one old partition and Oracle Optimizer ignore inactive partition while creating an execution plan? I'm asking the question because sometimes partition pruning is not working as expected.
It is not like you are ignoring those partition actually, but the conditions that you are putting in your queries were conditions, so it will directly fetching those data, and if touch upon those partitions only. So there is nothing called like you can ignore those partitions.
All right, Chandan. And next question is, can you please confirm lifecycle management features available from which Oracle database version? Can you please suggest best practice in selecting partition key so partition pruning works perfectly?
Yeah, so data lifecycle management is available from the 12C onwards. 12C onwards, we have introduced, heat map and ADO in advanced compression. So you can, if you have not upgraded your database, 12C or, onwards, 12C onwards, then you should upgrade your database to take this advantage. And I should suggest 12C is already out of support now. You should upgrade to the 19C database to having the long-term support, and in the 19C you will have these features and functionalities to achieve this. Regarding the the selecting the partition key for the partition pruning to work perfectly, right? So it is depend on the which strategy you are following to mm, do the data partitioning, and the purpose of the partition of your data. For data lifecycle management, the interval partition and the date partition are the the key things that you need to look on the data which is having those certain data in your table. So you can do the interval and date partition with that, and you can achieve the data lifecycle management.
Thank you so much, Chandan. And we have one more question now for Rodrigo. I have it to enable something inside database for heat map. It's global, or I have it to enable table per table or object by object. What the impact in database performance when enable heat map?
Yeah, so to enable heat map, there is a init parameter, is a heat underscore map. You have to on it. Heat map, alter system, set parameter, heat underscore map equal to on. Just fire this command. Your heat map is enabled for entire database. Okay, it is not for any particular table. It is for entire database. We can set to the at database level, and we have the multi-tenant architecture going forward from the 19C onwards. So you can enable this parameter at the PDB level rather having at the container database. You can enable at the PDB level as well. So it is not for any particular table, but it is for your entire PDB or entire container database.
Thank you so much, Chandan. And any other questions? If anyone has any other question, please feel free to share with us by the chat. And if not, Chandan, thank you so much for taking the time to present to the Asia-Pac community, to participate in another event from the Asia-Pac community, and also for taking the time and also for answering questions and be available always when we require. Thank you so much.
Yeah, thank you, Francisco. Thank you very much for inviting me for this session. It's my pleasure to share my knowledge to the community. Thank you very much.
Thank you. And as the replays will be available until the 20th of May to everyone, this will be uploaded tomorrow for this session. If you are watching the replay and have any questions, please feel free to contact Chandan directly to his email or Twitter or LinkedIn account as shown in the presentation. If you have any issues to contacting Chandan, you can always contact with the organization, and we can then forward all your questions to Chandan offline. Saying that, thank you so much again, Chandan. Thank you so much, everyone. We still have one more session for today, and then tomorrow we have 4 amazing sessions too. And please take care and be safe, everyone. Thank you, Chandan, again.
Yeah, thank you.
Bye-bye, everyone.